All right. Yeah, I'm recording it. So yesterday we went over um, how to do this, and this is just a chance for you to practice. I didn't give you the same elements. I gave you something with a little bit different. But if you are listening to the process, you should be able to do this. So we're eventually trying to get to a Lewis dot formula for the combination of aluminum fluorine forming ions. Okay, so we've got to physically move electrons. If it's forming an ion, we're physically moving electrons from one thing to another. Okay, so then we're going to write the orbital notation for aluminum first, so we can see what unpaired electrons we have. And aluminum is located right here on the periodic table. So we're going to fill up 1s, 2s, 1s, 2s, 2p, 3s, and 1 electron in 3p. Remember, the boxes are there, the orbitals are there, even if I only have 1 electron in that sublevel. Okay, so that's aluminum. We're putting it together with fluorine. Let's see, how do I want to do this? I'm going to put fluorine. No, I'm going to put fluorine right here. Okay. So fluorine only has 1s electrons. Remember, helium actually belongs over here, and we're doing s, p, d, and f sublevel regions. So 1s, 2s, and 1, 2, 3, 4, 5 electrons in 2p. All right. So if you look at fluorine, fluorine just needs 1 electron here in order to have a full outer energy level. This big number 2 here and here is part of the outer energy level, showing that these orbitals are all part of the outer energy level. So I want, for fluorine anyway, it seems a lot easier to move 1 electron down here. Aluminum wants to lose, I can gain 1, 2, 3, 4, 5 electrons, or lose 3 to get a full outer energy level. If I lose 3, I get the 2p, 2s sublevels full. And so the combination of the two is pretty clear. I think you're going to take electrons from aluminum and put them into fluorine. Okay? So I'm going to illustrate it this way today. I'm going to take and strike out this electron and move it down here. Okay? But while that takes care of fluorine, aluminum still needs to lose 2 more electrons. But before I leave fluorine entirely, since I put an extra electron in there, I need to also put a negative charge on it. Got that? Okay. Now aluminum right now has lost an electron, so right now we have a single plus charge on it. Okay. There's lots of ways to illustrate this. I'm just doing it a little bit differently today so that you can see different ways of thinking about it. So I need another fluorine now to get rid of these other electrons, or at least 1 more in this case. And I can strike out this electron now and move it down here. That gives me a negative charge on this fluorine, and now this aluminum has 2 plus charges. All right, so I still need to get rid of 1 more electron, so I still need another fluorine. Slide it up a bit. Alright, so there's where I can put that last electron here from aluminum. And we get another negative charge on this fluorine and another positive charge on this aluminum. Okay? Alright. So if I have an aluminum with a 3 plus charge, and I add that together with fluorine with a 1 negative charge, but I actually have 3 fluorines. Okay? The 3 plus charge here and 3 1 negative charge particles here, if I add those together, the result is a 0 charge. And that's what I want my final compound to have, a 0 charge. Okay? So the final compound will be 1 aluminum and 3 fluorines. And you show 3 fluorines with a subscript. Okay? Yeah. Move it up a little bit. Okay. Now, I've canceled the charges here. I'm showing here how I've canceled the charges. You don't put a 0 charge on a compound. If there's no charge, you just put nothing. Okay? So that's why there's no charge written up here now. It's just AF subscript 3 to show there are 3 fluorines and 1 aluminum. Does that make sense? So this 3 right here, that's a coefficient here at this point, becomes a subscript at that point. Alright? Now we're going to do the same thing with electron dots, or we're going to get the same result anyway. So we started out with aluminum with, in the outermost energy level, this is called the valence level, we originally had 1, 2, 3 electrons in aluminum. So if we're using electron dots, I'm going to write the aluminum symbol and put 3 dots around it. It doesn't really matter on which of the 3 sides I put it on. Remember, the pattern is that you put 1 on each of the 4 sides until you get them all filled up, then you can pair them up. Well, I'm not getting to a point of having to pair up anything here. Okay? And then we got these fluorines, and fluorines have in the outermost energy level. So 3 is the outermost primary energy level. 3s and 3p are part of the outermost energy level. Is the highest energy level for aluminum, but 2 is the highest primary energy level for fluorine. And in 2, I've got 1, 2, 3, 4, 5, 6, 7 electrons before I move anything around. So here's where I have to pair them up. 1, 2, 3, 4, 5, 6, 7 electrons. Okay? All right. I can see here using this electron dot notation. This is what this is called, electron dot formulas or electron dot notation. Both of these, I've got them in electron dot notation or electron dot formulas I've written for them. So I can see here that if I put 1 more electron here, I'll have 8 electrons in this valence level I'm showing around fluorine. Kind of showing the same thing here. With 7 electrons, I need 1 more. Only now it's a little bit easier. It makes it a lot easier when we're doing covalent bonding. Ionic bonding, it's somewhat easier. Okay? So, and aluminum has 3. So with electron dot formulas, if I'm doing ions, I can either get rid of all the electrons that I'm showing, or I can put 8 around there to be where I want to be. Now, there are exceptions to that, but that's what we're aiming toward. Okay? So at least initially, I can take this electron and move it right down here. So that one's going to go away. Okay? And I'll move it down there. So that takes care of fluorine. Fluorine now has the 8 electrons it wants to have. I still need to get rid of 2 more electrons from aluminum. So I need another fluorine here. And then I can take this electron and move it down here. Okay. And that takes care of that fluorine. But aluminum still got another electron it wants to get rid of. So let's take this one and move it down here. Okay. So now the aluminum has gotten rid of all of its electrons. Now what you don't show when you're showing these electron dot formulas like this is how you have a lower energy level that's now full since we've gotten rid of this upper level. Okay? But you just have to know that. So this is something you have to just kind of understand that's not written out for you when you're using Lewis dots or electron dots. Okay? Now, since I got rid of 3 electrons, I still have that 3 plus charge up here. Since I've added electrons to each of these, I've got a negative charge on each of these. Okay? And now that I've gotten all that done, I want to take and make or show what results from it. Okay? So I've got one aluminum with a 3+ charge. I've got 1, 2, 3 fluorines. And each fluorine has a negative charge because I've added one electron to it. And I'm at the same place I was over here when I got to this point. That makes sense? So now all I have to do is finish putting it together the same way we did down here. So our subscript 3, our coefficient 3 here becomes a subscript 3 right there. Okay? Any questions?